the last topic that we're going to be covering in right triangles is the idea of special right triangles. I'd like to preface this set of notes by saying that you can use Pythagorean theorem or trig on special right triangles if you don't recognize them. But again, it's kind of like if we can find little shortcuts or ways to make our problems easier, then we want to do that. And special right triangles is kind of an example of that. So we have two types of special right triangles. The first is what we call the isosceles right triangle, or you'll also hear it referred to as the 45-45-90 right triangle. Isosceles, of course, means a triangle with two congruent legs. So in an isosceles right triangle, our two legs are exactly the same length, and our hypotenuse, of course, is the biggest side. So that one is different. It's also known as the 45-45-90 because in an isosceles triangle, the base angles, of course, are also congruent. So these two angle measurements would have to be 45 degrees each to combine with the 90-degree angle that we have to make it a right triangle for all three angles to equal 90 degrees. Where you'll see an isosceles right triangle a lot of times is if we have a square, which of course is made up by four congruent sides and four right angles. And if we cut it diagonally in half, then we create two 45-45-90 or two isosceles right triangles, as you can see here by this blinking triangle. Okay, so why are we talking about it? The reason we're talking about it is because um, the sides of a 45-45-90 right triangle always occur in a particular ratio. The legs are always at a ratio of 1 to 1 because they're congruent. So if this side is 1, then this side has to be 1. Or if this side is 2, then this side has to be 2. Again, always making a ratio that will reduce to 1 to 1, or a fraction that will reduce to 1 over 1. So if this side were 7, then this side would also have to be 7. The hypotenuse is also always at the same ratio. The hypotenuse is at a ratio to the other two legs at a rate of square root of 2. And we can use Pythagorean theorem to see why this happens. If we plug in our two legs as being 1 squared and 1 squared, we can find our c squared using Pythagorean theorem and then solving for c. And we can see that if our two legs are 1 and 1, then our hypotenuse would always be the square root of 2. The reason we bring this up is because then you can use this ratio to find the missing side lengths of any isosceles right triangle. So our ratio of hypotenuse to leg, you don't really need a ratio to find the legs because again, they're congruent, but is 1 to the square root of 2. So we're talking about this part of the ratio right here, either one of the legs. And so let's say you knew that the hypotenuse was 3, you could find the missing side by the missing leg by putting an x there, cross multiplying, and then solving for your x. Again, you can find this also using trig or Pythagorean theorem. It's just kind of a faster way to do it. Okay, the second type of special right triangle is called the 30-60-90 right triangle. And you'll see this oftentimes in an equilateral triangle that is cut down the middle. And an equilateral triangle, of course, has 360-degree angles. So this angle, and this angle up at the top would be 60. And so, of course, if we cut that triangle in half, that would make this angle 30. So we have a 30, 60, 90-degree right triangle. So, of course, we have the hypotenuse, and then our other two legs we call the long leg and the short leg. So the long leg and the short leg are in a ratio with the hypotenuse at a rate of 1 to the square root of 3 to 2. So the short leg is always half the hypotenuse, or in other words, the hypotenuse is always double the short leg. And then the long leg is the short leg times the square root of 3. Again, we can use a ratio and a proportion to set up, to solve for a missing side length by cross multiplying and then solving for our variable. So this is how we're going to use the um, ratios to help us solve for missing sides of special right triangles. But again, you can, of course, always use Pythagorean theorem or trig depending on what the problem gives you.